Right, hello. I had to cancel office hours, so I wanted to cover some of the questions that are on the quiz and the homework this weekend. So it's going to be base behavior, directionality, and interpreting organic mechanisms. Okay, so in this question, we're told that select the base that are weaker than the nucleophile used in this reaction. Okay, so just keep in mind the nucleophile is here. It's initiating the reaction. The arrow is starting with it. So we're really just saying which of these bases are weaker than this substance. Okay, so let's go through the analysis. So stronger means that the lone pair is the least stable, right? So strongest when the lone pair are the least stable. So what we're really looking for is if it's weaker, then we need to see some form of stabilization, right? So let's take a look at A. So we have a lone pair, nitrogen, and then attached to nitrogen, there's an electronegative element. Induction is stabilizing the lone pair because oxygen's more electronegative than nitrogen. It's reducing electron-electron repulsions, and so A would be a weaker base than the nucleophile in the reaction. Let's look at B. Now, there's no electronegative element here, but here instead of 2 carbons being present, on option B, there's only 1 carbon. So there's definitely going to be a difference in base strength because B is going to be weaker because there's going to be 1 less carbon destabilizing it, right? So if you have less destabilization, then you're weaker since destabilization makes bases stronger. Right, and then we look at C. We have a single bond, double bond connector. Resonance is present. This is a significant reduction in base behavior. And so here we have weaker. So all 3 options are ways to make the nucleophile weaker. Remove a carbon, add an electronegative atom like oxygen, or add resonance. Those are all ways to weaken a base. So here we're given 3 different molecules, and so we're going to answer sequentially these questions. What's the most basic center of each molecule? And then which base is probably the weakest, and which base is the strongest, and why? Right, so the most basic is going to be the nitrogen atom, right? The least stable atom is always going to be the most basic, right? The least stable lone pair. So in all 3 of these molecules, nitrogen has the least stable lone pair and is the base center. Okay. Now the next question is, out of the 3, which one's the weakest? Okay, so there we need to analyze the different nitrogen environments. What we're looking for something that's weaker is that it's stabilized by resonance or it has some electronegative atom close to it. And so if we look at norepinephrine, here we see we only have 1 carbon destabilizing and 2 hydrogens, right? They're fairly neutral, and an oxygen atom stabilizing. So 1 destabilizing feature of carbon and 1 stabilizing feature of oxygen. So in this case, we would consider this substance to be weakest. All right, so now what we can do is sort of organize the acids. So strongest acid is the one that has the greatest number of 2 carbons donating in, right? 2 carbons destabilizing the base and no oxygen atom close to it. So that's going to be the methyltyramine. 2 carbons, no oxygens. Then what we have is the the epinephrine, in which we have two carbons destabilizing, just like methyltyramine, but there's an oxygen atom stabilizing, so that's going to weaken it a bit. And then for the arguments we talked about in terms of norepinephrine, it only has one carbon destabilizing, but still has the oxygen atom stabilizing. So in that case, this would be the weakest group. So you want to make sure that you can sort of identify these type of features and how we can assign the relative base behavior. Consider the following acid-base reaction. Which one is the strongest base? Okay, so let's identify the bases here. These are the negatively charged ions. So we have OH minus. This is more electronegative. The negative charges on O is more electronegative, more stable than if we put the negative charge on a carbon atom, which is less electronegative, less stable, and therefore a stronger base. So in that case, that would be the strongest base. Now we could also do another analysis, like is this reactant favored or product favored? That's good to practice. So that means if OH minus is the weakest base, then the other side has to be the stronger base. If OH minus is the weakest base, then its conjugate acid must be the strongest acid. And if the strongest base is C minus, then its conjugate must be the weakest acid, right? So that's the nature of conjugates. The strongest acid must have the weakest base, and vice versa. So we see that this would be reactant favored, since the weakest substances are in the reactants. And at least for the purposes of this question, the strongest base is the negatively charged carbon, which we can't see in water. That's how reactive it is. All right, what about this reaction? Is this reaction product favored or reactant favored? Well, we just have to ask ourselves on which side of the reaction is the weakest base. So we identify the bases as the neutral nitrogens. They're not the positively charged substances, which are acids. So we just look at the two base centers. The one in the reactants has two carbons destabilizing the nitrogen center. The one in the products only has one carbon destabilizing the nitrogen center. So the one that has the product base that only has one carbon, we call this the weakest base. The one on the reactants is the strongest base. If this is the weakest base, then in the reactants, this must be the strongest conjugate acid. And then if the strongest base is in the reactants, then its conjugate acid must be weakest. So you see, every time we identify the weakest base, we already know the weakest acid will always be on the same side as it, and we will know the directionality. That means that K is greater than 1, product favored, because the weakest base is a product. All right, so this is from Unit 7, Analyzing Mechanisms. So what we're going to do is take a look at each of the 3 steps here. So I know it just asks for species A, but we kind of have to know everything about the mechanism to talk about A. All right, so the first thing we do is we see that step 1 is an acid-base step. We have OH minus, the nucleophile, reacting with OH, COH. It breaks the OH bond and forms water. Okay, so this is our acid-base reaction. And just for practice, we know that this is going to be product favored because the weakest base is in the products, right? So this is the weakest base. This is the strongest base. Okay, no, I didn't ask for that, but we're just adding that in there. Step 2, once we make this product, then the double bond in the ring acts as the nucleophile, reacts at the electrophilic center of carbon dioxide, which is partial plus, and makes a new molecule. And we know this reaction is this can't be an acid-base reaction because it's not a transfer of hydrogen, but we also know here that delta H must be less than 0 because we're net bond forming. The third step here, just going to get my double bonds right. The third step is to take our product from step 2, react it with water, another acid-base reaction, we form an acid plus OH minus. All right, so this should look like, what is it? It's Kb, right? So Kb, it's got to be reactant favored with Kb, but we see by regenerating OH minus, which started off as a reactant, we now know that the role of hydroxide as a catalyst. It's really important to sort of decompose each of these steps. It really helps to draw them out, follow the reaction. Okay, and so what is likely true for the second step in the mechanism? All right, so let's take a look at that. Second step in the mechanism. So let's do the first step. First step is the nucleophile is O minus, right? That's the group. It's pointing at the electrophilic center. So it's coming in, it's making a CO bond and breaking a CO bond. Sort of makes this very, very strange looking intermediate. Right, so we're breaking a CO bond, right? This one here, I'm going to put a star by it. So we're breaking that bond and we're forming the new CO bond. So that's delta H more or less 0 for step 1. Step 2 is a lot clearer because we start off with this this tetrahedral carbon with 4 things attached to it. And then we're shown that the bond breaks, becomes a new lone pair, forming chloride. So in this case, we are just breaking a carbon-chlorine bond, not forming any other bonds. This has to be endothermic. Okay, so let's summarize here for the Unit 7. Nucleophiles always initiate the reaction. If it's molecule to molecule, it's a lone pair on either oxygen or nitrogen or a double bond pointing at the electrophilic center of another molecule. This is going to form another bond, right? It's going to form a new bond. It could also be the double bond, right? But it's always going to form a new bond. If it's a double bond, it'll also form a carbocation on the other carbon, the other double bonded carbon. So one carbon will form the new bond. Another carbon will have a hole because it took both electrons over here to make the new bond, and that's leaving the carbocation. So we'll see that today in class. Okay, but what if so these are external arrows, right? So it's really it's a lot more straightforward to follow external arrows, but internal arrows, they come in 2 types. Let's take a look at those. You can have a lone pair, a line, so this is internal, so it's within a molecule. It starts at a lone pair and points at a bond. So what does that mean? That means a lone pair to a bond means you're making a new bond formed, creating a double bond, right? So this is going to turn into, right, so that lone pair now became this new bond, right? So that's what an internal, one version of the internal arrow can look like. The other version is when it starts at the double bond and points up at the atom. So it starts the double bond, points up at the atom. That means we're breaking one of those 2 bonds and forming a lone pair. And in that case, the delta H would be positive. So these are all the different types of questions we ask in terms of arrows. Okay, so these are all these questions were taken from Pop Quiz 10 and from the homework. I hope this has helped clarify some of the ideas we're going to be asking you.